Hello, everyone, and welcome back to AR Insider Innovators. I'm your host, Mike Boland, and our guest today is Luis Ramirez, who's founder and CEO of Mawari. So, Luis, welcome to the program.
Hello, everyone.
So, we have a lot to get into, and thanks for joining us today, Luis. But before we sort of get into it, for those unfamiliar with you and Mawari as a company, tell us a little bit about it.
Mawari is one of those companies that started a while ago. Now it's almost 8 years. So it was in the wave of 2017 where there were, a lot of more VR than AR startups at the time. And our vision was okay, at some point in time, the entire media ecosystem will become frameless. So, what do we mean by that? Is that today we see everything into the screens, right? You have your phone, you have your TV, everything is confined to the screen. But following the same theory of VR, I mean, the screen comes just right through your eyes, right? And then the environment becomes the user interface, which in the end is what we call today spatial computing, right? So that was our vision. So that's why we were inspired. Okay, so we need to create a company that will help accelerate the arrival of this content because we see, yeah, that there's a huge gap, and that's where the what we're still doing is the same. Is actually streaming 3D content to AR devices. We realized at the time that the current technology stack and infrastructure is not suitable for scaling this the way we imagine it as in movies and Ready Player One, Minority Report, or other ones. Uh, so that's when we embarked into this mission. That it has been a roller coaster, to be honest, because it is not only just creating an AR startup. It was about creating a deep tech startup in an emerging and frontier technology industry.
Think, it's a classic infrastructure play and optimization, the picks and shovels, the things that you don't hear about as much in the trade press, and things that aren't as present on the front end, so they're not as top of mind for a lot of people. But it's sort of the unsung heroes of XR, and I think that I think now would be a good time to actually take a step back and talk a little bit more about that, what the actual sort of platform and the technology is doing. And I think that one of the ways that really helped me understand it early on is a few years ago when you explained it to me in that, you know, everyone that's a media consumer sort of has this expectation. We've been conditioned to believe that content in our media landscape these days is streamed, one, and then two, it's just sort of seamlessly streamed. I mean, you turn on Netflix and it just works. And then there's this sort of I guess, expectation that you extrapolate from there, or people extrapolate from there, that with XR, it's just going to stream, it's just going to work. However, that's not necessarily the case because of high bitrate content, bandwidth heavy content. The current streaming infrastructure, which is built for 2D things like Netflix, is just not going to cut it. So tell us about that sort of underlying challenge.
Sure. Okay. It's very complex challenge, honestly speaking. So yeah, the consumer expectation, and that's our elevator pitch. So when you press play on Netflix, you just say it yourself. Within less than a second, it just works in any device that you have, and you don't think about it anymore. On top of that is unlimited content. So it means you do not need to download it, and that's it. And you just enjoy. And then once you finish watching your show or your movie, you forget about it and you come.
Yeah, we're all spoiled, right? We're
Yep.
spoiled.
So, and even more now, the new generations with TikTok and all this. I mean, some content is engaging content. We can call it is 2 or 5 seconds, and
Yeah.
that's enough. So just imagine, like for I went, for example, Half Life Alex was a super hit, but it was, I think, like 50 or 60 or 80 gigabytes to download before I could actually play the game.
Yeah.
So I was just laughing. I mean, people don't have, I mean, unless you're a hardcore fan, you don't have
You're not gonna wait.
patience.
Yeah.
Yeah. So even though there will be 5G, 6G, or 10G, whatever you call it, I mean, 80 gigabytes is 80 gigabytes. So it's not something that will download in milliseconds, right? So so that's the first challenge is that uh, XR content or true native XR content is in 3D. And 3D runs on game engines, right? In Unreal, in Unity. Um, Meta is creating their own engine as well. And that the game engines are built in a way that the content is locally on the device, and then that content logic is rendered in real time on the display, and this is what you see. That's how game engines were designed. Game engines weren't designed to render remotely and to render in a remote server and then display it on a in a remote display. So
Mhm.
that's the big challenge. So when it comes to 2D, like let's think about remote desktop. I mean, you. I hope you have used remote desktop at some
Sure.
point
Yep.
in your life. It even still has a lag, right? You don't care because it's a 2D screen and you're just moving the
It's
mouse.
just mouse clicks and things. Yeah, like latency's okay in that case.
Yeah, but when it comes to okay, so the screen is in your eyes and your brain is thinking that that's the entire environment, and then there's a lag on the transmission. There's something called the screen lock happens. So the screen you move your head, but the screen stays where in the previous frame,
Yeah.
and that messes with your brain. And very sensitive people right away get motion sickness. I mean, even in the early days of VR, that was a problem, like the frame rate and the refresh rate, even with
Mhm.
wired headsets. So now we have very stable headsets that run at a very high frame rate. But how big is this and how heavy it is not something that you can wear 24/7 or like most of the day like this, right? So so for example, this one even has two processors because they are specialized for each thing of a spatial computing. So so if our vision is that if you really want to make XR mainstream, it needs to be just as easy and accessible as Netflix. That's the bottom line. That's when people won't think about it, and they will just focus on the content. So okay, so that's one big problem. So the latency. If we use the traditional video streaming pipeline, you're rendering the frame remotely, and if it arrives later than the frame rate of the headset, you have that lag, and it's not natural to watch the content.
So what you've done is basically create the rendering further downstream or closer to the user at a very high level. Is that a fair thing to say?
Yeah, we tackle the problem from different angles actually. So and this is why we have a patented technology. So there's part in which we part of the architecture is more related to nearby servers so that we
Mhm.
can cut the round trip latency, but that's not just enough because internet always has different conditions, so it's not a magic solution. The second one is that we kind of re-envision how to do to see the rendering pipeline. And we understood that, for example, what it is essential for the devices is to actually all the spatial computing always needs to be on device
Yeah.
because that's actually less than the 10 milliseconds of latency that you need, and that's actually higher frequency than the frame rate of the um, of the content itself. So with that in mind, it's like, okay, so if if the special computing needs to happen on device, we need to split what's being rendered or in within the device and the remote server. So this is what it allows us to actually mitigate the latency, but also give a sense of there's no latency, which is basically what T-Mobile's CTO mentioned, that is near zero latency, the feeling that we have because there's parallel processing. The device is always working and is rendering the frame rate at the local frame rate of the device. So your 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 brain is locked into that frame rate, and then heavy content then gets streamed into the scene as you need it.
I see.
So
So the when you say split rendering, where the split happens is different sort of aspects of the content, and then also where do the interactions come in? Is that also split in terms of is that local or I mean, I guess it has to be because that's where it's coming from, but the rendering of interactions versus sort of input versus output, I guess is the best way to put it.
Well, that's a very interesting question, and that's something that we're still solving, but also is a split because there are some interactions that like a game or physics that need to be in instant, otherwise it doesn't feel correct. But there are some other interactions that, yeah, if it's a much more complex thing, it can be rendered on the server, and if the round trip latency is good enough, you don't notice. So that's in a nutshell. That's the problem that we're solving is how to uh the first problem that we solve is how to stream 3D specifically to AR, because that's the other thing. Like VR, in the end is video, right? That is video wrapped around your headset, and it
Mhm.
has and you make it stereoscopic, and then it looks 3D. So, but it can still work in the video pipeline, but you just need the ideal conditions of the network and a lot of tricks. But the XR is different. XR or augmented reality, I mean, the environment is your world. So you really need to embed the objects into the scene. So that's the other difference. Like, let's imagine if there's a virtual object here and you can still see me in front because it's rendered in a different place. So you lose the occlusion, and sometimes the occlusion also creates that depth and height perception, a lot of things that make AR what it is. So that's also why this split rendering approach that we took makes sense, because it allows you to embed the stream content into the 3D scene, and it blends naturally with occlusion and all the advances that the headsets now have.
Well, it seems like the requirements for AR compared to VR are also more complex because of the sort of spatial understanding, the scene understanding, and the perception engines that are at work to sense the surroundings. So it's a lot more input, right?
Correct. And that input and processing again needs to happen on the device,
That's
not
gotta
on.
happen locally, of course.
Yeah.
Yeah. Now, you mentioned you're attacking this from several angles, and we just went through the sort of networking aspect. There are also things you've done in the past, such as compression technology. So it seems like there's a lot to this. It's streamlining the content itself. It is working on the infrastructure and the networking in a way that will orient it to render properly. What other parts haven't we discussed in terms of the aspects of what you're building?
Sure. Okay. So, well, the first is, I guess, let's call it like the core technology, which is, we could call it compression, but it's in the end is the full framework of approach of rendering,
It's
and
line.
it's the entire pipeline. Let's call it like the 3D streaming pipeline. That's the first thing that we focused on. But as we build this 3D streaming pipeline that includes compression, that includes, yeah, rearranging the rendering pipeline, et cetera, we realized that we needed low latency in any case, and we needed a very different server architecture. So that's the networking component. But from the networking component, then we realize, okay, so centralized cloud per se doesn't really help to what we do. We need distributed compute, and that's the other part that we are addressing when it comes to the technical problem. But also, what we understood very early enough that also it was very difficult to understand for a lot of people back in 2018 and 2019 is that okay, so it's not like a video game that you have a very simple NPC that just says hello or bye and that's it, right? Like we were asked to stream a intelligent digital human
Mhm.
that can give you any type of answer. So right now, you send a question to ChatGPT or to any LLM, it goes to the cloud, does the inferencing, and it comes back, right? And if it's a complex question, the reply doesn't come within less than a second. It could be a second or two, but because it is text, it's okay. I mean, you look around, you actually either change the tab of your browser and then come back when the answer is back and it's totally okay. But when it's a digital human, especially this next to you as an avatar, you expect like what we're talking, like you expect a real time response. Otherwise, it feels uncanny. So that's part of the uncanny valley. So we also understood that the AI inferencing, at the time we would just call it the AI processing of the answer, needs to be also into the same network pipeline so that we can reduce the round trip from, because just imagine the complexity, okay, so of what's happening. So I'm seeing a digital human that is being rendered on the cloud in front of me. Then I ask a question. So my voice goes to a very separate server in a very remote location that is completely different where the content is being rendered to process what I said, understand it, come back with an answer, and then it needs to send back the answer to the rendering server so that the voice and the lip sync of the digital human
Yeah.
is it actually is coherent to what he or she is replying to you, right?
Mhm.
So see, it's a triangle. So if we put that on the same network, to streamline the pipeline and you reduce the latency. So that's something that also that we understood early enough, and for not only for just let's call it 3D content, because 3D content is interactive, but let's call it intelligent or a highly interactive 3D content, which has that AI component. The architecture that we built is highly crucial because this content, if it's rendered remotely, it needs to have like that response time of the compute as well.
Absolutely. So that all makes sense. And one thing that we can kind of get into next is your most recent development in all of this. I think you've done a good job sort of unraveling for us a lot of the principles behind the technologies you're building and how that manifests in both your rendering pipeline, the networking sort of that needs to happen. The most recent development and how that's all sort of materialized is with your decentralized infrastructure. And this relates to something you said earlier, which is that a lot of the sort of the server providers are focused on AI, and even prior to that, they didn't have enough graphical compute muscle at the edge. So you've decided to actually take the very ambitious step to build it, but not just build it, but in a very efficient way that sort of crowdsources a lot of that decentralized, geographically decentralized compute power. And a lot of this is based on the principles of DePIN. Some from the sort of Web3 era might remember this word DePIN that was being used a lot, which is decentralized physical infrastructure networks. And DePIN is one of the things that I think has come out of Web3 that has been sort of underrated and might like emerge as really one of the most significant things that actually could provide sort of value. And you're basing a lot of this on that sort of principle of DePIN. So I guess the question is, tell us about how you're sort of internalizing those principles and building a decentralized network to sort of gain that efficient and geographically distributed sort of compute power that's needed that brings things closer to the node.
Okay, so yeah, that is correct. It is a fact that to solve this scalability issue, we need distributed compute. But there should be a different way rather than just putting insane capital onto it to scale. And that's when, yes, I saw, okay, we need to do it in a crowdsourced way. And that's when it was parallel to AWE in 2021. I started seeing that there were a lot of Web3 startups, but some of them actually to me were very interesting. That's Render Network and then Helium, which a render network is similar, but for 2D, they crowdsource other people's GPUs to render movies and offline content. Um, Big production studios use them because instead of having a big server farm in-house, they can just have it remotely and they just pay for on demand for the work. So it is Web3, but it's a real business and it provides a real value. And similarly, Helium has started as an IoT network in which you could buy their device and set it up on your home, and this would replicate the signal for this IoT network. That was a bit early. They were highly successful in terms of scaling. They went from 0 to probably, I think, 800,000 hotspots in less than 6 months. I don't quote me here because I didn't start Helium, but it was something along those
Yeah,
lines.
approximately. We can leave it at
So
that.
so that to me told me, okay, so if there's a good mission, if there's a good business, and there's a good incentivization model, it is possible to crowdsource uh, this type of infrastructure. That's when I came back to my co-founders and I say, Web3 is the way we need to go. They look at me like, what? Because Web3 has had this reputation of just being fraud
Yeah,
in
a
the
lot of
end.
vapor. Yeah.
And but in the end, the deeping within Web3 is one of the categories that actually does provide value. That
Mhm.
there's a real use case and a real world problem behind, and it's being solved through decentralized infrastructure and through blockchain in the end. So okay, so we need distributed compute, and there are two ways to do it: is build your own distributed network of servers or crowdsource it. And this is where the blockchain Web3 component falls in because to orchestrate and align a lot of people into, okay, I'm well incentivized to keep providing the server with the service level agreement that we need, etc., etc. Blockchain and works because it's a public database that shows your performance, etc., etc. And you can create incentive mechanisms within that network. So this is why we made that decision to go into Web3. And interestingly enough, we were able to raise from Web 2, well, let's not call it Web 2, let's call it traditional investors and Web 3 investors both converged because what we're doing actually makes sense for a real world application.
So tell us about the incentives and tell us about the orientation and construction of this network. And we use the term crowdsource a few times. Tell us about the individuals who are helping you to scale this network and how they're being financially motivated to do so.
Okay, so think about Uber or Airbnb. So you have your apartment, um, maybe unutilized, and you want to monetize that unutilized time, right?
Mhm.
So you go into Airbnb and you subscribe your apartment and you put it up for rent. And if someone rents it, you get the money and then you pay a fee to Airbnb, similar to Uber. Okay, so you get a car, you get your license, you subscribe to Uber, and and you get paid for the work that you provide. So it's exactly the same principle here. Is we have some demand of infrastructure, so our community provides their resources and they get paid for the work they do. So that's the simple way to explain it. It's orchestrated and underlined by a blockchain system. So this we did created what we called decentralized infrastructure offering this year. We the network itself in the architecture had different type of nodes. In blockchain, they're called nodes, which is our servers. So we have the rendering and streaming node, which is traditional like a GPU node. We have a quality of service node that actually ensures that the SLA of the GPUs is correct. Then we have a checker node, what we call it the guardian node. That's where we did the DIO. The guardian node job is to make sure that the network integrity is always there. So since it's a decentralized and trustless system, the system itself needs to self-correct itself, right? So this is why you have Bitcoin miners, you have
Mhm.
Ethereum validators, etc., etc. So they play a role to secure the network to make sure the integrity is always there. So there needs to be a police or authorities, but since it's a decentralized system, it cannot be Mawari. That's the role of the guardian nodes. So they verify that the stream, that everything, every single aspect of the network, it is um, it is operating correctly. And after they validate this, then is when the network participants get rewarded for their work.
So who is the perfect candidate to be sort of to hold a guardian node? Someone that has sort of a minimally spec'd hardware, probably maybe some idle time where that resource can be lent to the network. What are some of the other things that you're finding that folks are sort of most successful as playing the role of a guardian node?
The DIO is more widely open. We run it in 2025. It recently closed on the 3rd of December, and it was super successful. I'm so surprised because the original supply that we envisioned it was 300,000 servers. So we actually have 180,000 reserves. So next year we will start Mawari network. Hopefully, I don't think everybody will start their server at the same time, but within some time in 2026, we will have 180,000 servers operating. And that tells you the power of crowdsourcing and the power of when people are aligned into a mission and they believe and in this, you can scale much faster.
Yeah, that's the first time I've heard that number, and I feel like we buried the lead. That's quite impressive. Congratulations. Now, for those listening, um, what's like the next opportunity to participate? You mentioned that the DIO ended December 3rd. Is this the first of many? What's sort of the next opportunity for folks to participate?
Okay, so there are a couple things coming in. So we will have the DIO season two. That's that's probably gonna happen around Q2, I think.
Okay.
So there's still going to be a chance to join of network, of course. And currently, we are focusing on the other XR problem, which is the use case in the end. So um, also, since now it's almost 9 years in the end, is we learned is the picks and shovels make sense when the industry is hot, meaning
When there's a
that
gold rush.
when there's a gold rush. But right now there's no
Right.
gold rush, right? So we need to catalyze the gold rush too in the end. And it's happening. I mean, Meta, Apple, Google are doing an excellent job and advancing these devices. We know it's happening soon. I mean, 10 years ago, uh, we say the same, but it's very different now.
Yeah,
Like,
it is because they finally, I think, found the right formula, the right product market fit in like the glasses you're wearing right now. That is something that is mainstream friendly and scalable. And the numbers are validating that. If you look at, according to our calculations, Meta Ray-Ban smart glasses, or excuse me, Ray-Ban Meta smart glasses have reached about 5 million units in lifetime sales, and that's over a period of about 2 years. And that's by far the most scale achieved by any XR product to date.
exactly. And it's gonna get better and better. Like
Yeah.
even my wife told me, okay, I want some of this. They look cool.
Yep.
So there you go. So
Well, and not only that, I should add to that, just briefly, that market validation that Meta has, demonstrated has attracted several roadmap pivots from the other tech giants that are into XR.
mm,
Android XR, the Android XR sort of ecosystem is going to be a huge enabler in terms of lowering barriers for OEMs to build devices, for developers to build things. It's gonna do for XR what Android did for smartphones
exactly.
10 years ago. But the interesting thing is it's not gonna be a two-horse race like we had in the smartphone revolution, where you have sort of a vertically integrated player like Apple doing all its own stuff. Then you have Android sort of, you know, being an enabler for all the other, device manufacturers. You have those too, but now we also have Snap, we have Meta, we have several others, so it's gonna be interesting in terms of but all that's culminating and we're projecting a very big year in terms of device launches in 2026 with all these sort of roadmap pivots to chase, again, what Meta has validated, and then the real sort of, I think, revenue impact is gonna come in calendar year 2027 because a lot of these devices are reaching the market late next year. But it seems like with that timing, to your point, it's different than, it's sort of, it's like a cry wolf thing in terms of like, have we lost credibility as an industry because we've said so many times, this is the year, this is the year.
This
This
is the
is
year.
coming.
Yeah.
Yeah. So I'm careful in what I'm saying, but again, I rest on the real sort of validation of those unit sales as one of the points of evidence. But I'm
Yeah.
sorry, go on.
So no, you're absolutely right. It's gonna be early 2027, and I again don't mark my words because yeah, we're not Nostradamus, but maybe probably 2028 is when the first killer app will come. At Mawari, what we're doing is trying to contribute to that.
So sort of winding down, what haven't we talked about? What can we expect from Mawari in 2026?
Okay, so we have the core technology, the infrastructure, the tools to stream, and then the application layer with the end user. And it's all now, yeah, is the entire vision working from 1 to 360 in million ifs. So that's what's very exciting, because we've been doing this for many years, and some of these parts have been working because we have been streaming already from the centralized server since last year. But now everything is integrated into one full pipeline or cycle, which proves that our vision can be realized. So this is very exciting for me.
That's great, and I think that's a good place to end it. So I want to thank you, Luis, for joining us.
Likewise, thanks for inviting me, and happy to be here again.
So thank you all for watching. This has been AR Insider Innovators. Our guest today was Luis Ramirez. You can find out more about Luis and Mawari in the links below, excuse me. And you can read AR Insider's daily insights and market coverage at arinsider.co. So please like, comment, and share if you like this video. That helps others find us. So I'm Mike Boland. Thanks for watching, and see you next time.